Hello, today we are going to discuss how to write, solve, and graph inequalities. First, let's review the inequality symbols. Is less than or equal to is B. Less than points to the left, and the little sign right here means or equal to. Is at least means greater than or equal to. Which is A. Is fewer than, it's the same as is less than, which is symbol D. And is greater than, we could also say is more than, is the symbol. And less than points to the left. Okay, we use inequality symbols for a couple of reasons, but mainly to compare numbers. So 9 is less than 11. Negative 10 is greater than negative 15. Negative 3 is less than 0. And then 0.5 is equal to 0.5. Now, we could also say that 9 is less than or equal to 11, which is true. We could also say that negative 10 is greater than or equal to negative 15, because that's true, it's greater than. We could say that 0.5 is less than or equal to or greater than or equal to 0.5. And the statement would still be true. And we could also say for negative 3 that negative 3 is less than or equal to 0. The or part means that it could be either the less than or the equal to. So these are all true statements here. Okay? Typically we're just going to write, if we have two integers like we do here, or two real numbers, we just write the sign that's most true. Okay, inequalities can be described in words as we've seen up at the top. Let's write an inequality to represent each situation. And then we're going to graph the inequality on a number line. So a number that's greater than 3. Okay, so any number, so you can use x, n, a, whatever variable you want. I'm going to use n to represent number, is greater than 3. Okay, on a number line, this has one boundary. The boundary is 3. So I'm going to put 3 on here. We know that 4, 5, and 6 go this way. We know that 2, 1, and 0 go this way. So we're not going to label it. We're just going to put our boundary. Okay, we want numbers greater than 3, which would be 4, 5, 6, and everything above. So we would shade the number line like this. And we would fill in the arrow to say that it continues as far as the number line goes. Okay, this is not equal to 3, however, so we use an open circle to describe that it is not equal to. Now, also, these can be written in the other direction. So, for example, we could write this as 3 is less than our numbers, which means 3 is the lowest, and all the numbers are higher than 3. These can read either direction. Okay, B, you must be at least 14 years of age. At least means you could be 14 or older. So I would use A for age. 14 or older means greater than or equal to 14. And on a number line, our boundary's at 14. We want everything shaded that is older than 14, which would be to the right. And we want an equal to this sign, so we need a filled in boundary because 14 is included. And again, we could write this as 14 is less than or equal to A, which means 14 is the lowest age. Okay, letter C. At a pond, you must return any fish that you catch if it weighs less than 3 pounds. Okay, so it's too small to keep. Less than 3 pounds would be a weight which is less than 3. So on a number line, the boundary is at 3. We want everything less than that, so we shade to the left. And we cannot include exactly 3 pounds, so we'll use an open circle for that one. We could also write this as 3 is greater than the weight, which means 3 is the highest, 3 is higher than the weights I can accept, 3 pounds is. Okay, now we are going to solve a couple. So we solve inequalities the same way that we solve equations. We use our adding on both sides, subtracting on both sides, all the same properties, except for one difference. When you are multiplying or dividing, you have to watch out. If you multiply or divide each side of the inequality by a negative real number, it requires that the inequality sign reverses. So I'll give you a number or an example with numbers. Okay, let's say that we know a true statement like -2 is less than 4. If I were to take that and multiply each side by -1, let's say, and I can do this because I'm doing this on each side, that's a property of equality. On the left I would get +2, and on the right I would get -4. Can we keep the sign and keep this a true statement? Would 2 be less than -4? And that is not true. So we have to reverse the sign. And that's really because the relationship changes. So when we're solving, we have to look out for this. So here we have one where we have a variable on both sides. So I'm going to subtract 4y from both sides, just like I was solving an equation. And I would get -3 is less than 1y plus 2. And I'm going to subtract 2 from both sides. So I get -5 is less than y. I don't have to divide by anything here, so I don't have to worry about this. There's no sign reversal. Okay, if I'm going to graph this, my boundary is at -5. It's not equal to, so I know it's an open circle. But this is saying that -5 is less than my solutions. I could also say that my solutions are greater than -5. Either way, I'm shading to the right. Number 5, the only thing I would have to do here is divide both sides by -0.3. Now, watch out. I'm dividing by a negative, which means the sign is going to reverse. So it's going to reverse from greater than or equal to less than or equal to. On the left, I get 1x. And on the right, I get -40. Again, we could also say that x is greater than or equal to -40. On a number line, my boundary would be at -40. I know that -39 is on the right, and I know that -41 is on the left, so I only need to put this one boundary. It's an equal to, so it's going to be a filled in circle, and it's greater than, so I know all the numbers greater than would go to the right. For the other two examples, I'd like you to try these on your own and then show your teacher.